All right, guys, so here's chapter one. So we start off in ecology, and the first thing we're going to talk about with ecology is animal behavior. So going through as to why does a crab have one claw instead of two? Why do they use that as a defense mechanism? What's the benefit to that? How is it passed down? Is it a genetic thing? Is it an environment thing? Is it nature versus nurture? So as we go through and we start to look at it, behavior is how we act. It's controlled by our nervous system, but why do we behave that way? Why do organisms choose the way that they are? Ultimately, it comes to the fact of it benefited them somehow, some way, in the form of possible natural selection. So when we start to look at some of the reasons why we have the behaviors we do, what stimulus does it? So for you, that time that you hear the alarm clock, what is your response? So the behavior it elicits is the fact that you should be up. How does the animal experience during growth and development influence its response? So if you have ever been around a dog from a shelter who was abused as a puppy, someone goes to pet it and it pushes away and it's like, no, don't touch me. That's kind of something that it's responded to from when it was little. And in some cases, that same puppy, that if you go to pet it, its response can be one of two things. That of aggression, I'm going to protect myself, fight or flight, and it's going to choose to fight. Or you have that other puppy who rolls over, shows its belly, and maybe possibly will urinate on itself, submissive urination, because it realizes if I just roll over and pee, I won't get hurt. I'm just saying I'm defenseless, and maybe they won't hurt me as bad. So you have different organisms and how they respond. Now, typically when we talk about it's an organism's response to evolutionary history. So that crab may have realized, being that it's a little small crustacean in the ocean and there's other things that can eat it, it may realize if I'm going to live and I'm going to stay around, I need to have some sort of defense. So kind of like how porcupines have quills, crabs have got their claws, other organisms have fangs, so things like that. They realize some of these defense mechanisms came in handy in order for them to live just a little bit longer. All right? So when we start to talk about that behavioral ecology, we're going to look at how do organisms respond based on their environment. So when we go through and we start to talk about some of those triggers, our whole thing is to figure out why do they do it. So we talk about our fixed action pattern. Basically, this is something that they're going to do. Basically, once something starts, it's going to continue on and finish it out. So can be all sorts of things. For some organisms, it's a constant thing. So when we start to talk about sea turtles and organisms that are migratory, soon as the process or soon as the magnetic piece in their head triggers that our poles or that time of year or barometric pressures adjust, some organisms are triggered to migrate. Some of it's a temperature one. So whenever those things hit, they're like, oh, stop what we're doing, head to wherever we got to go. And they'll go and go and go until they end up where they're supposed to be. So AKA sea turtles going back to the beach that they were birthed at. All right. When we start to talk about stickleback, and these are going to be things that you're going to see on the AP exam quite a bit at times because they've been studied so substantially. These guys, kind of like when you hear the whole Toro, when the bull sees red, will charge. Same thing when you start to talk about sticklebacks. So when we look at a stickleback, they're set to attack anytime they see red. So whether it's red on a bobber or red on a fish, they're going to attack. It's kind of their little trigger. So as we talked about with migration, there's a lot of organisms that will migrate, some small distances, some extremely large distances. Kind of like you guys are looking at with your great white shark right now. And how it's going over long distances. What pushes organisms to do that? It's for all sorts of different reasons. A lot of times it is for food. A lot of them are triggered based off of clock. So if you've ever heard of the phrase circadian rhythm will affect how certain organisms move, but it's typically not a long distance thing. That's the part that adjusts your sleep-wake cycle. And as I said before, the magnetic field will impact. Birds have actually tissue that is a trigger that has works with the Earth's magnetic field, and that's what they use in order to figure out their migration. So if you have something that impacts their magnetic field perception, you impact the way that they migrate. So, aka wildebeest, they'll travel over, crocodile infested waters in order to get to a different watering hole or to get to food sources as seasons begin to change on the savanna. So, as we talked about, that circadian rhythm, that's what keeps us in our sleep-wake cycle. So, anytime your circadian rhythm is off, you feel it. Some of you, now that you're off of your summer cycle, you're back into school and you're like, oh, it's noon, I should still be asleep. So your circadian rhythm is turned slightly around. Same thing happens with people who go from that are working and they go to the night shift. They have to sleep during the day and be up when it's dark. They have typically a transition period for that, and it's a little bit more complicated. Hence why they develop blackout curtains. So in order for people to adjust to that so they could actually sleep when it's really bright outside. Same thing for people in Alaska during summer when it's really bright all day long. Conversely, they have the daylight simulating lamps that help them to cope with the lack of light during the winter months. So there's different ways that us as humans have helped to adjust our circadian rhythm based on our lifestyle choices or location that we live. Now, when we talk about signals or communication, that's different for different organisms, and there's different ways it can be done. Communication can be done by body language, as you and I know. So if someone walks up to you and goes and gives you that nice little cheesy smile, you're typically not going to go, I hate you back. You're going to typically smile and have some little communication back to them. Signal that it's basically, I understood what you just did. Other organisms, that can be an actual tone. It can be like with us, as you're hearing notes now, I'm communicating to you, your communication, your reception of the communication goes, I get that, I write it down on my notes. If you don't understand the words that are coming out of my mouth, I know some of the words are big, but if you don't understand, then communication is lost. So other things that you can do are chemical communication. So organisms will use things such as pheromones. And they'll use that, as it talks about with the fruit fly below, on how it responds. Same thing with bees. Bees are big. Anytime you talk about your colonial organisms, pheromones and hormone transmission is big about understanding the hierarchy in that type of grouping. Same thing with your ants and so forth. So in this particular case, how they tap, how they slap their wings, that tells them what's going on. So different organisms have a different response, like we talked about with the bee. Where they are and where they've been, the chemicals on them, kind of like if you have a dog, anytime you go out and come back, the dog's like, hey, where you been? And they're going to smell and see, what are you doing? Now, pheromones, us as humans, we have a limited perception of them. Kind of ties into the fact that if you've ever been around a person and you're like, they're not my type, I don't really dig them, but there's something about them, not their personality, not like, hey, they're a great person. It's something about them that you can't pick up, but there's something that causes you to be interested in that other person. And it could be a subtle response to their pheromones that they give off. We still give them off. We're nowhere close to other organisms, other mammals, whose pheromones are quite permeating. Ours are more subtle, but we still have a slight ability to perceive them. And we talked about that with the honeybee and being able to adjust, and same thing with moths and their perception. Those organisms have a strong perception of pheromones. Same thing goes when we talk about fish. So in this particular case, so you put an alarm in, one gets a signal, the rest of them respond. Kind of like teachers in class, and whenever we do that whole raise your hand, if I'm raising my hand, the whole class needs to start getting quiet. So one kid notices the hand up, they raise their hand, other kids go, why are your hand up? Then they notice another kid's hand goes up. And all of a sudden they go, oh, and then they clue into the teacher and they go, they want silence. So it kind of works in that same way. We trigger and do the same response, except for it's not a chemical based one, it's just that. Okay? So as we talked about, the next one, we're going to go through and look at nocturnal versus diurnal. So nocturnal are going to be organisms that work at night, such as your bats and things, which is why they use echolocation. That's their response to working in nighttime. Their eyesight is going to be different than ours. So we're not nocturnal organisms, which is one reason why it's difficult for us to see at night. We are diurnal. And so, which means you're typically up during the day and asleep at night, versus your nocturnal organisms are reversed. They typically are asleep during the day and up at night. And so they use their other senses a bit more profoundly than we do. So that's where those pieces will kick in. All right. So then we start to talk about innate behavior. There's certain things that is just how they are set up. So if you've ever been around someone and they typically have that dark sense of humor and they've always had it even from a kid, it's kind of one of their innate behaviors. Some people suck their thumbs. It's one of their behaviors that they've got that's fixed into who they are. I get stressed, I suck my thumb. I get stressed, I play in my hair. There's just certain things that people have that's their go-to. Okay? So now when we start to talk about other behaviors, such as cross-fostering. Cross-fostering means that it's something that you picked up from someone else in order to impact your behavior. So there may have been something that a teacher taught you back when you were little, that now you have that behavior, or something you learned from your grandma, your grandpa, your aunt, your uncle, a brother or sister. May not have been a good behavior, may have been a great behavior, depending on the influence that they had on you. Okay? So kind of like when we talked about in your book, it talks about how there's different mice. Some are peaceful and some are aggressive. You raise the peaceful with the aggressive, they possibly will pick up those tendencies, and vice versa. So it's one of those, when you start to look at how they respond, you are, in some ways, because of the cross-fostering of who you're around, you're a product of your environment. Now the question is, us as humans, we're cognizant enough to sit there and say, I know better than that. Even though that's what I was taught, that may not have been the best choice. Okay? We also start to see this when we start to talk about twin studies. There's certain behavior that we notice that twins will just naturally do, whether they live close to each other or whether they're on the other side of the globe. There's certain traits, certain things that they will respond. If you talk to any twins, there's certain parts, certain connection that other humans that are not twins don't have that same response to each other. There's some sort of connection that we talk about when they're twins. And so it's a very unique study. We'll get into more of those as we get into genetics and things like that. When we start to talk about our learned behavior, we can learn to modify. We're flexible human beings, aka you can teach an old dog new tricks. So, but we do have the issue of nature versus nurture. There is some genetic aspect to this. Now, when we start to talk about imprinting, a big group that can undergo imprinting are birds, reptiles, organisms that come fresh out of an egg and you handle them and they get used to you. So when they talk about, if you go into a store and you go to look at birds, they're like, these were hand raised. So in other words, what they taught those birds to understand is human hands don't do harm. Human hands help. Human hands give you food. Human hands you can perch on, and things like that. They teach the birds that we are okay during that sensitive period. Same thing goes with babies. Babies, if you're holding them, talking to them, when we talk about our impressionable years, first 5 years of life, that's whenever you're trying to teach a baby how to speak, learn colors. That's why when you go through it, it's like, what does a dog say? Dog says woof. And you talk to little babies like this. You're trying to get their brain set up. So during that sensitive period, kind of like you when you were little, if your parents held you, talked to you, sang to you, made you do puzzles, that sensitive period, your brain increased tremendously. Same thing happens to a new baby bird. Its brain is taking in the world for the first time. Its brain is absorbing and making connections. The connection is, as I see humans as food, safety, and support, that's imprinted into their brain, which is also the same reason why when you're around wildlife, they'll warn you, don't mess with wildlife at a park. They don't want the wildlife to see humans as their only source. So that's where we start to have that little fine line with certain organisms. That's a no. All right. So I'm going to pause it here, And we'll continue on with chapter 51 here in a moment.